Hello, Algebra 2! Hope you guys are having a great day. We are moving on to 2.5, which is all about complicated numbers and numbers that don't exist. So that's super exciting. So we're going to look at what an imaginary number is, what a complex number is, and then look at how to solve equations that have some roots with imaginary answers. So, we're going to start by looking at a graph of a function, x squared plus 4. Now, if you think about this function, right, it's a parabola, right, and the plus 4, hopefully at this point you know that moves it up 4, 1, 2, 3, 4, which means that its vertex is at 0, 4. So, I will draw that in. So if you notice, right, this clearly does not intersect the x-axis. So that means that there's no x-intercepts. Does that mean there's no zeros? Well, that's what we're going to talk about today. And I kind of already hinted about it earlier in earlier classes, but we're going to actually talk about what an imaginary number is today. So, things that we're going to need. The imaginary unit, okay? And the imaginary unit is I, a little lowercase I. And basically it's a shorthand. It just represents the number square root of -1. Okay, now looking at as a big picture, right? Complex numbers are all the numbers that mathematicians know exist. Okay? Kind-ish, you know. So, complex numbers include real numbers, but it also includes imaginary numbers. So you've got kind of two branches or two subsets of complex numbers, imaginary and real. Your real numbers are any numbers that don't have I, any number that you can think of, like square root of 2, or 5, or -17, or pi. All of those are real numbers. Imaginary numbers are any numbers that have, they're like attached to an I. They're multiplied by I, essentially. So like 7i, or pi I, or square root of 2i, or 2/3 I, or 10i. Yeah, those are imaginary numbers. And complex numbers are any combination of real numbers and imaginary numbers. So, with addition or subtraction. So like 7 plus 2i would be a complex number. And the funky thing is, either the real part or the imaginary part could be 0. So even real numbers are complex numbers, and imaginary numbers are complex numbers. And I'll talk more about that in a second. So any complex number can be written in this form, a plus bi, where a is a real number and b is also a real number. And so basically, right, 2 plus 3i is a complex number. 3i is a complex number because a is just 0, right? So it's still a complex number. And a real number like 2 by itself, that is also a complex number because the b part is just 0 because it's plus 0i. So all the numbers that we know about are complex numbers. They can be written like a plus bi. And then if there's two parts, if there's an a and a b, then you call each thing individually, like this a is called the real part, which makes sense because it's like a real number. And then this part is called the imaginary part. And something that's really important is that algebraically, I kind of treat like an x-ish kind of thing. So you can't combine a and bi. All you can do is leave it as 2 plus 3i. That's not the same thing. Don't write this down because it's not right. That's not the same as 5i. Okay, you can't combine those. So you can only combine like terms. So for example, if I have something like 2i plus 3i, that is 5i, right? Because I have 2 imaginary numbers plus 3 imaginary numbers. How many imaginary numbers do I have now? 5! Okay? So a complex number has something called a complex conjugate. And basically all that does is it negates, makes negative, negatizes the imaginary part. So an easy way to say that is that the complex conjugate of a plus bi is a minus bi. So for example, if I have something like 2 minus 3i, its complex conjugate is make the imaginary part negative. So 2 plus 3i. Okay, it's just a vocab word. There's nothing significant about it just yet. There will be, and we'll talk about it. But really, all you need to know is the vocab word at the moment, and that it's making the imaginary part negative, not the second part, but the imaginary part. Okay? So let's try a few examples. So simplify the square root of negative 16. Well, that's the same thing as the square root of negative 1 times 16, which is the same thing as the square root of negative 1 times the square root of 16. So the square root of negative 1 is I, and the square root of 16 is 4. So I times 4. And usually we put the number first, so 4i, like that. So square root of negative 16 is equal to 4i. The square root of negative 50 you could write as the square root of negative 1 times 25 times 2. And I broke that up into 25 and 2 because I know 25 is a perfect square. So I can pull that out. So that's the square root of negative 1 times the square root of 25 times the square root of 2. So this actually ends up being I times 5 times the square root of 2. So your final answer would be 5i root 2. Typically roots go last so that you don't get confused as far as like what's underneath the root and what's not. And just, I mean, this is a common mistake that I see a lot of places, but this is not addition, right? These are all multiplied together, right? You didn't see addition anywhere here. So be careful about how you write it. You can include the dots if you need to for multiplication, or you can just bump up the numbers next to each other. I'm going to actually skip C for now, just in case we run out of time. I'd rather go over these first, and then we'll see how we do on time. So next part, find solutions. Okay, I mean, I think at this point you have enough information to do all these problems, so you might want to try them first and then see how you do. And then, pause it, check your answers. So for number 1, you have x squared plus 32 equals 0. So I just move the 32 to the other side. I get x squared equals negative 32. And then I take the square root of both sides, and when I take the square root, I get a plus or minus. So I get x equals plus or minus the square root of 32. Now, if you can simplify it, simplify the square root, because it's much nicer when things are simplified. So I know 32 is 16 times 2, so I'm going to rewrite that as the plus or minus square root of negative 1 times 16 times 2, right? Square root of negative 1 is just I. Square root of 16 is 4. And the square root of 2 can't be simplified, so you have to leave it as the square root of 2. And you get your plus or minus there. So you have 2 solutions to this equation. Alright, next problem, negative 5 equals x squared plus 2x. So it's still a quadratic, so you want to, you could add the 5 to the other side, and when you do that, you get 0 equals x squared plus 2x plus 5. And you could try to factor it to find the zeros, or, but there's nothing that multiplies to 5 that adds to 2. So it's not going to factor nicely. So we could complete the square. So let's do that. Let's do x squared plus 2x. And then remember, I'm adding in this 2 divided by 2, and then square it and bring it back in, subtract it out, you know, that whole bit. See the previous video if you're still confused on that. Plus 1, so you add 1 in, and then I need to do plus 5, and I need to subtract out 1. So that equals 0, and I get 0 equals. This first part factors to x plus 1 squared plus 4. So now you can subtract the 4 to the other side. So I get negative 4 equals x plus 1 squared. Take the square root of both sides. Hey, look at that. I've got the square root of a negative number. Square root of negative 4 is just 2i. And that equals x, and you get a plus or minus, right? Because you took the square root. You get plus or minus square root of negative 4. So x plus 1 equals plus or minus 2i, which then bring the negative 1 over to the other side. I get negative 1 plus or minus 2i is what x is equal to. Okay, so my two solutions to this equation are negative 1 plus 2i and negative 1 minus 2i. I don't know if you noticed or anything, but it just so happens that those two answers are complex conjugates of each other. Negative 1 plus 2i and negative 1 minus 2i. So that's cool. Coincidence? I think not. Next ones are pretty simple. It's just finding the complex conjugate. The complex conjugate of 5 plus 4i. Remember, you make the imaginary part negative. So the complex conjugate of that is just 5 minus 4i. Complex conjugate of 3 minus I is 3 plus I. Really not that hard. Number 3, I plus root 5. Could trip you up, because usually you're used to making the second part negative, but you are always making the imaginary part negative. So in this case, you need to make it negative I plus root 5 is the complex conjugate. And then last but not least, negative 4i, the complex conjugate, right? Because this is really essentially 0 minus 4i. So the complex conjugate is 0 plus 4i, right? So my complex conjugate is just positive 4i. Cool. All right, last little thing that you need to know, and you saw this in problem number 2, is that if you get that a complex number is a solution to a quadratic, or actually any equation, then you are always going to have two answers, at least two answers, right? That complex number and its conjugate. So you're always going to have a complex number and its conjugate that are paired together as solutions to a problem. So if one complex number is a solution to a quadratic, then so is a complex conjugate. And another way to think about that is that if a plus bi is a solution to an equation, then so is a minus bi. Okay, and now we can go back to the other problem that I skipped. Okay, so I want to start with I to the 0. Okay, I to the 0 is, well, anything to the 0 is 1. Okay, so I to the 0 is still 1. I to the first is just I, right? I mean, that makes sense. Anything to the first power is just itself. Now, I squared gets a little funky, right? Because you've got an I squared, and I is actually equal to the square root of negative 1. So I take the square root of negative 1 and I square it. Well, a square and a square root, those cancel each other out. So I actually just end up with negative 1. So I squared equals negative 1. If I move on to I to the third, I'm going to actually write I to the third as I squared times I, right? That's still 3 i's. I times I times I, right? So I squared is negative 1, and I'm multiplying that by I, so I end up with negative I. Do the same thing for I to the fourth. Well, I to the fourth is the same thing as I squared times I squared, so that's actually negative 1 times negative 1. That equals positive 1, and so on. So what's kind of cool is there's actually a pattern